Caden, when I move over to that board over there, I'm going to trust you to turn the camera for me. All right, so a couple of things I want to point out, and I need us to be aware of when we're working with these things. So, when I look at this, a lot of us have a very good, correct idea, but we need to learn from a couple of things. First off, please note I'm only asking you to do the medium section right now. We haven't learned how to do the spicy stuff yet. Okay? Okay. And I need you to remember, because I had this question come up from, I can't remember, it was somebody who was saying, hey, Mr. Kinney, when I look here, how do I see the y-intercept? Right? Now remember, what form is this?
Standard.
Right here in the bottom section?
Oh,
yeah, it's factored form. So when I look around the room, some of us are getting our features right, but we're not following the #1 recommendation I made. What was the first thing I recommend you do if you're trying to find those features?
Put your equations in.
Yeah, I write my equations above it, guys. That's going to help me identify those different pieces of the equation and what it's going to look like in the graph. What is it for factored form?
A times x plus R1 times
8 times 8 with parentheses x minus R1.
So remember, when it's the x, it's minus. When it's grouped with the x like that, it's x minus R1, and that's going to play into an important feature in a second. Now, when I look up here at this medium, what does A tell me for that standard form?
Concavity.
So it's concave up, okay? So now, what is A for you to tell me that it's concave up? I don't see anything written there.
Positive.
So 1, we just know immediately, without knowing the number, it's a positive, right? There's no negative. But does anyone know what A is?
1.
Yeah. How many x squareds do I have? I have 1 of them. So A is understood to be 1. It's not written, but it's understood, okay? C. Actually, what does B tell us?
Slope.
Now, B would tell us slope if this was linear, but this is quadratic. Did I ever actually have you manipulate the slider for B? I did not. B on its own does not tell us one thing. And so there's a complicated piece that we'll look at the end of this that gives us the extra. Well, R1 and R2 are here with our factored form. But notice B on its own, it's not going to do anything. If you need to make a note of that to yourself in a second, do that. But be aware, I have students every year that I teach this, try to make B the x-intercept or the y-intercept or the vertex. That B on its own doesn't do anything. Okay? What is C though? Okay, so C is -3, but what does that tell me about?
Oh, y-intercept.
Y-intercept. The reason I bring this up is, if the y-intercept is here, am I seeing the y-intercept right away in the factored form? Remember, the y-intercept is immediately visible in standard form. That is a special feature of standard form. Standard form is the only form where I can immediately see the y-intercept. That doesn't mean I can't get it, but standard form is the only one where I can immediately see the y-intercept. And this should make sense. What do we know about every y-intercept that's ever existed?
X is 0.
The x is 0, right? So we substitute that in. What is 0 squared?
0.
Plus 2 times 0.
0.
So if we have a y-intercept, this becomes 0 and I'm just left with C. That's why I get this. But I want you to think about this one here. Once again, if I wanted the y-intercept, you don't need it. But someone was asking, how do I get that y-intercept? If I want the y-intercept, what is always going to be true, Caden, for that y-intercept?
It's gonna be there.
What? You're going to be there?
It's gonna be there.
It's going to be somewhere, right? But what do we need to know to get that y-intercept? Preston? What do we need to know and always remember to get that y-intercept? But if we have factored form, I don't have the C. Someone said it.
It's got to be 0.
What's got to be 0?
X.
X. Guys, you got to remember, if I'm looking for y-intercept, it doesn't matter what graph you're looking at, the y-intercept, the x is 0. So, now remember, that's why this became 0 and I was just left with C. But here, can I substitute 0 in?
Yeah.
But notice, that's not immediately visible. I'm not asking you, you don't have to do this, because that's not immediately visible. However, can you find the y-intercept?
Yes.
Yes. What features of the parabola can you immediately see from that factored form? It wasn't y-intercept, it was x-intercepts. I need you to keep in mind that from that factored form, I can immediately see my x-intercepts. Okay? So factored form, you're looking for what? Factored form, you're looking for x-intercepts right away, okay?
Yep.
You can still find the y-intercept, but the goal is concavity and x-intercepts. And so this group wrote -1 and 1, and they ordered it, so they're saying this is where we get our -1 and this is where we get our +1. But why are they getting a -1 out of x plus 1?
We gotta switch
It's
our
the
signs.
opposite.
So remember how we talked yesterday, because it's x minus r1 and x minus r2, I need the, starts with an O. Opposite, right? Those signs switch. But you also said something, Tobias?
Zero product.
Right? Zero product property. Remember, I need to get out a 0. If I put a 1 in here, is 1 plus 1 0? No, 1 plus 1 is 2. I need this to be a
What?
You said 1+1?
Yes.
what?
He thought you said 0 plus 1.
1 plus 1 is 2. I need this to be 0, so -1 plus 1 is 0, okay? So we need the opposite so that I can create that 0, okay? So keep that in mind when we're looking at this. And based on that, I can do a quick sketch. Now, there's two things I want to point out I need you to be aware of. One, we got our x-intercepts, right? And that's all we have besides the fact that this one's going to be concave. See, there's my A right there, isn't it?
Yeah.
So this is parabola's going to be concave. Remember, concave down like a
Frown.
right? So remember, if A is negative, negative's a bad thing, so we're going to be concave
Damn.
down, and concave down is like a
Frown.
frown. That's going to help, please, because there's a lot of confusion with this. Now, do note, that is all you have to do to get the target portion on the proficiency scale. If it's factored form, you need to find x-intercepts and sketch it based off of x-intercepts and concavity. If you find the y-intercept, so this is right there. Okay, come on. I got two more final details I need everyone to pay attention to, because these are some of the most common mistakes that I see every year, and already on the demonstrated understanding, my first block missed this, and it bit several of them in the butt. When I look here at this one, the most common mistake that students make is they put a y-intercept at -3 and they make it concave up like this. This is the only time when I would say that that is incorrect for the y-intercept.
That hurt.
I'm sorry, Mr.
How hard is it to hold on to a calculator and
I
not break
forgot, I
it?
forgot I had it.
Clearly not. Okay. So, does anyone know why that is?
Because it ain't a vertex.
So we need to remember that's the y-intercept. It could be the vertex, but have we found out if that's the vertex or not?
No.
No. Guys, don't put your vertex at the y-intercept unless you know for sure that that's your vertex. I could do that here because I know, we'll talk about it more later, that my vertex is in the middle because of the line of symmetry. So I knew that was going to be the vertex for the factored form. That's not going to be my vertex. We will talk about how to know what the vertex is soon. It either needs to look like this with a vertex in the fourth quadrant, or it could look like this with a vertex in the third quadrant. Either one would be acceptable. But do not put your vertex at the y-intercept. Does that make sense? You're comfy with that? Now, the next thing, and this is something that I forgot to address in first block and I had to tell them today. Procedural error, procedural error, procedural error, procedural error. What's the issue with all of these? Is there
That's
enough?
three.
That's
symmetrical.
Well, that's pretty symmetrical right there, but what are those ends? They are straight up and down. Guys, if you put your ends as straight up and down, one, that's not a parabola. Two, that's not even a function. Like, I want you to think about this. If I put a vertical line here, is that vertical line touching the relation at just one point?
Yeah.
Is it?
No, it's touching the whole thing.
It's touching the whole thing. It's touching infinitely many points. If I look over here, though, look. If I draw a vertical line, how many times is it touching that graph? That purple? It's only once. Here?
One.
Once. Guys, when you do a parabola, it has to go out and up. It is a smooth curve. And I get that we haven't stressed about that. But you have got to, like, this one even curves back inside. So is that a function?
No.
Guys, to be a quadratic function, each input maps to one and only one output. Do not forget that. So please make a note to yourself. If you are doing that, put it on your check your understanding, put it on your fair model. Hey, these end behaviors cannot, that's what we call it, the end behavior. It cannot be straight up and down. It cannot curve back in. It's got to go out and up or out and down. Okay? So please update any notes you need to your future forgetful self on these, the notes section of these fair models. And we will come back and continue with the Desmos activity in a second. So one person per group, you negotiate who it is, get your iPads out, but update your notes first. By the way, where should we be updating notes? Yeah, but which check your understanding? Vertex form? No, not vertex form. We haven't done vertex form. I'm saying factored form or quadratic. So guys, please make sure you pay attention to factored form or quadratic. Equation. We've now looked at factored and standard. The factored and standard told us about x-intercepts, they told us about y-intercepts, they told us about the concavity, right? So most of this foundation piece, hopefully we're good on. The last one we have not done is vertex form, and we're about to get there. Hopefully we can graph quadratic functions by hand for the factored form and standard form at this point. We're about to do vertex form. And we need to be able to identify line of symmetry, the concavity, vertex, roots, and zeros. By the way, yes, let's go ahead and say this. Well, just wanted to point this out. I don't need all those purples. With a root, what did we say a root connects to?
Like the bottom.
You good?
Like the bottom of the ground.
It was the what?
Like the bottom of the plane.
Not the bottom of that function. What are you saying, Tosh? Connects to the x-axis, meaning they're called x-intercepts, right. Hey guys, look. Right here, these are my x-intercepts. Please note, what is my y value?
0.
What is that output?
0.
0. Okay. I need you to pay attention to this vocabulary because this is important. So when we talk about roots, it has a slightly different context, but if you hear the word root, you can also immediately think of the word 0.
Yep.
So whatever your root is, that is also what your 0 will be.
Yeah.
So if I say R1 is equal to 3,
There's 0. What happened?
people talking while I'm trying to teach, and so that means multiple people not gonna learn it. All right, listen, if I were to say R1 is equal to 3, that means the root is 3, and so my 0 will be 3, okay? So the term 0, the term root have slightly different meanings, but they have the same values. So whatever your root is, that's what your 0 is going to be as well. We will explore more next unit why there's a difference there, okay? A root is from the expression, the zeros from the equation. So that's the difference, but or for the function. So those are the slight differences, but we'll get there more later. All right, so what form do we need to look at?
Vertex. Yeah, vertex.
Yeah, vertex.
I'm sorry, we just did factor with roots, didn't we?
Yeah, vertex.
We're now into vertex. So remember, the textbook just expects us to know stuff. Notice we are moving on from the standard. We're moving on from the standard and the factored form. I need you to practice with those check your understanding questions, ask questions if you need to. But we're moving into vertex. So if I were you, the Fourier model I have out is the vertex form one, because we're about to answer the questions and figure out how vertex form works. All right, here we go. We got this. I have confidence in you. Actually, I legitimately have a lot of confidence in you. Ready to get it. I have confidence in your abilities. All right. So we did slide 11 yesterday, yeah? Okay. So we are now on slide 12. Dewan, I hear you. I'll come and check in on you.
Okay.
So notice what form are we looking at this time? Vertex form.
I'll do better right now.
Oh, he's been there for forever. Okay. So what is the equation for vertex form?
A to the x, a parentheses, x minus 8, yep, where to the k, 30k.
Okay. Now, I haven't ever done this part of it before, so I'm about to do something a little bit different than I used to. And it's only going to take 1 to 2 minutes if we're engaged. Yep. Anybody have a prediction what A is going to do in this vertex form?
Concavity.
You think it might still change the concavity?
Yes, man.
Okay, so maybe, or it might change the y-intercept. So let's figure out, when we go to our vertical surfaces, what we think A is going to do. Our prediction is maybe it affects concavity. Now, before you do that though, I want to ask you an important question. When we talked about C, that was a point on the graph from the standard form. What was C from the standard form? It was our
Y-intercept.
y-intercept. R1 and R2 were key points on the graph. They were our what? Roots that gave us what points though? X-intercepts. Now in this vertex form, any guesses what H and K might make a prediction what H and K might relate to? Line of symmetry maybe? H and K in this vertex form, any guesses, other predictions about what it might connect to?
The vertex.
Maybe the vertex? Okay. So we have predictions about what A, H, and K might do. On slide, what is this, 12?
Yeah.
What are you manipulating and trying to figure out? A, right? Once you have a prediction, if it holds up, move on to slides 10, or slides 13, and then 14 and 15. We're going to try to find out what do A, H, and K do. All right, we've been doing this for a little while. We good? We know what we're about? Let's get after it. If you finish before we come back together, move on to the practice questions. And break.
He thinks he's a quarterback.
Right.
Messed up or something.
All right. So, recapping right here. Okay.
Come on, bro.
So, once again, just like before, what did A change about this parabola?
Everything.
Concavity.
Oh.
Now, so remember, okay, and I do need to say this. Each of these values will affect the y-intercept, the x-intercept, the vertex, things like that, okay? The real question, though, is what is it most closely affecting? And when we change A, that most closely affects the concavity. Okay? Notice when A is positive, that parabola is concave what? Up. As soon as A becomes negative, that parabola is concave down, right? Negative 0.1, we got concave down parabola. Alright? So A is controlling the concavity. Make sure you are clear, not just A changes concavity, right? But when A is positive, let's be more precise, don't use that word it, what is concaves up? The parabola. And so parabola is
Yep.
concave up, okay?
Yep.
And I need you to be careful with this.
Bless you.
Okay? I cannot tell you how often I hear or I see students write 3 equals concave up. That's not accurate.
Oh.
What is 3?
The H. My H.
But what determines concavity?
Well,
The A, right? So in this case, A would equal 3, so the parabola is concave up, right? Be careful with your language, because 3 is a number. 3 is not concavity. 3 is a number, so that is different than concavity. It just tells us what the concavity is. Yes.
I got right all that.
Is it really hard to say A equals 3, so
No, I'm talking
concave?
like if it was a test or something like that. Yeah.
Okay, that's showing evidence of understanding. Now, we talked about this before we left, right? So H changes X, K changes Y, but guys, when we're talking about the vertex form, we're not talking about any generic points. What X value is that H changing? What X value is that H changing?
My vertex.
So remember what form we have?
Vertex.
Vertex form, so what is it changing?
The vertex.
The vertex, right? Notice, what is my H right now in this problem? 3. What is the X value of my vertex? 3. If I change H to -2, what's my X value of my vertex now? -2. K right now is -4. What's the Y value of my vertex? -4. I change K to 5, or to 4. Let's go to 5. K goes to 5. What's the Y value of my vertex now? 5. Please notice, does it affect my x-intercepts?
No.
No.
Yep.
Yeah, it is.
I was saying, earlier, I had x-intercepts, right?
Yep.
Do I even have x-intercepts now?
No, I thought you were talking about the H.
Well, my question and my point is this. Does this affect the x-intercepts?
Yes.
Yes. But does it define the x-intercepts?
No.
And that's the difference, right? So remember, R1 and R2, they will affect the vertex, they will affect the y-intercept, but what are R1 and R2? Those are the roots for the x-intercepts. The H and the K, will they affect the x-intercepts and the y-intercept? Yes. But what are H and K actually?
Vertex.
So H changes the x value, notice not intercept, x value of the what? Vertex. K changes the y value of the vertex. So if I were to ask you, what is a way to write the vertex based on this? What are the coordinates of that vertex?
-2 and 5.
Based on this.
Oh.
What key model?
Okay, let me do this then.
X.
8,8.
I'm going to make up an equation. Anyone have an idea what the vertex for this one would be?
4, -4.
-4 to the second power.
So first off, we need two values. We need an
X and a
and
Y.
a y.
It gonna be -4. It gonna be -4 and 2.
I think
-4
the
and
2
2?
be the x-axis. The -2.
Yeah, -4 and 2.
Okay.
Okay, so I've got -4 and 2. I've got -4 and -2.
Yeah.
Yeah.
I
Any
feel
other
like
thoughts?
it's gonna be -2.
I think like the first one's -2, then it'd be -4. I mean +4.
What?
You think -2 and then +4?
Yes, because I remember how we were doing the you know what I mean?
No.
Oh, he think we put the
I
switch
know
on.
what you mean.
Yeah.
He think we put the
Now,
switch.
there are so say that again. We're thinking some of the things might what?
He think
Oh no,
the
I thought we
switch.
was still back to going, bro.
We're on vertex.
I thought.
But I want us to look again at this. What determines the x value of the vertex?
Focus. I meant on the which color?
Concavity.
X.
No, it's right here. What
H.
determines
Oh, H.
the x value? The h,
Yes.
right? What do you think my h is again?
-4. Low.
That's okay.
I don't think my h is a -4.
Is it positive? Is it positive?
Is it positive?
I don't know. I'm asking.
I'm
You
asking
gotta get
you.
the reciprocal.
Yes, it's
Just do positive.
Why would it be positive?
Just do it inverse. We'll switch it. Change it. Change the
So
sign.
remember, guys, how we had x minus R1 and x minus R2 and we had to do the opposite?
Yeah.
Because it already has a minus?
Yeah.
What does this already have?
A
Minus,
I
right?
said that.
So H is not a negative 4, it's a positive 4. Now, I want you to remember a big thing to keep in mind with that to help explain it is we need the opposite so that this could become a what?
Zero.
0, right? Remember it had to become a 0?
Zero.
Right? What happens when I substitute a positive 4 into here? I get 4 minus 4 squared
Zero.
plus 2. What's 4 minus 4? It's
Zero.
0 again, isn't it? And so 0 squared is 0. What's 0 times 3? And then 0 plus 2. So that input of 4 has an output of
Zero.
2.
Oh, two. My fault.
So what we need to remember is inside of these parentheses, when it's with that x, I need the opposite. Because I need it to create that 0 again. Right? So I need the opposite so it creates the 0 again. But that means, what are we using to write the vertex? We're using
HK.
h and
K.
so what are the coordinates of every vertex?
Um.
What do we have to use? H and K. That's my vertex. Guys, if you are asked for a vertex, it doesn't matter what form you have,
Yeah.
if you can find H, H is the x value of your vertex. K is the
Y value.
y value of your vertex.
What if you ain't got an H value?
Huh? If it's a point, it's got an x value.
Oh,
Okay?
it should be.
Okay. I was about to say you can make another example.
No.
You joking now. You just joking at yeah.
So, before I give you, I don't know, 4 more examples with practice problems in the slides like we have for every other section, what I want y'all now to think about is this. What are the 5 features of a parabola? There's concavity, vertex, x-intercept, y-intercept, and line of symmetry. Hey, what's the only one we have not explored yet?
Line of symmetry.
Line of symmetry, okay? You're going to get some more practice, but leave this here, so whoever's group is this, don't erase this. We need to recognize whatever the h is, that's the x value of my vertex. Whatever the k is, that's the y value of my vertex. That's literally what we mean by h and k. But now, I want us to move to slide 16, where it asks you to adjust the value of a, h, and k, and observe what happens to the graph. Which values affect the line of symmetry? So, I want you to go to your vertical surfaces, I want you to manipulate a, h, and k, and figure out which one is changing this line of symmetry. Let's get up, let's go. Is that right, Jen Mike? What?
It's right. Get up and go down.
So, in a second, hey listen, in a second I'm going to transition up to the board, but I want to point out a couple of details that I'm seeing over here. I think everyone noticed, when we talk about A, H, and K in that vertex form,
Yes.
which part of that affected the line of symmetry?
H.
Just H.
Yes.
As you manipulated K, that line of symmetry stayed where it was. As you manipulated A, that line of symmetry stayed where it was. And I want to point out this right here, because we're going to use this statement heavily.
Yes.
H defines, I assume is what they were trying to say. Defines.
It's just a mistake, guys. It's okay.
Okay. H defines the line of symmetry. Is that what we were going for? H defines it. Okay. It
You don't know what define
is the
means?
definition. Like
said that?
it makes the line of symmetry what it is. Okay. So now let's talk about that a little bit more. If I can get one of y'all to turn the camera this way. When we say that H defines the line of symmetry, you good over there, Brady?
Yeah.
So right here, I need y'all to notice this. What is my H value right now?
7.
7, right?
Yes.
That is H. And when I look at this line of symmetry, what is true about What is, let me say it this way. What does every point on this line have in common?
7.
It's on the.
What is 7 though?
Oh,
It's
the
Y.
The X. Oh yeah.
The
The X.
X is equal to
7.
7. I don't know about you, but when I took Algebra 1 in geometry, I had to just memorize the fact that X equals gave me a vertical line and Y equals gave me a horizontal line. And that never made sense to me because the Y-axis is vertical, isn't it?
Yeah.
And an X-axis is horizontal, so why in the world is it that way? Well, here's why.
Yes.
If I say X equals 7, it doesn't matter what Y is. What is the X?
7.
So the point 76, does that satisfy the statement that X equals 7?
Most def.
The point 72, does that satisfy the statement that X equals 7?
Indeed.
Indeed. Right? So when we say X equals 7, we're identifying every point where the X value is what?
7.
Okay. And so notice that 7 is the same as my
H.
H.
Yeah.
So every line of symmetry that you will ever find has an X value equal to H.
Got it.
Notice that is an equation because the line of symmetry is not one value. The line of symmetry is literally a what?
A middle line.
A line of symmetry has to be the equation X equals H
Yeah.
because whatever that H value is, that's what the X value of every point on that line of symmetry is.
Got it.
What are your questions about that line of symmetry idea?
Nothing. That was
That makes sense.
looks straightforward.
Okay? So, with that in mind, we now should be able to look at this. What would be my concavity for this parabola?
-2. -2. Well, oh, down.
Thank you. Remember, A is -2, so the parabola is concave down.
Yes.
Okay? What else do I know about this parabola?
Wow.
Well, the x-intercept first of all, 4.
The x-intercept is 4.
Yes, the x is 4 and 0. 4 and 0.
What do y'all think?
No.
Anybody want to add on to it? Push back on that?
Push back.
-4 and 0.
-4 and 0?
Wow. Math, why?
What?
Because these now, wait.
No.
No, it's 4.
X intercept is our H.
Maddie, Jaquel, I need your eyes over here. Tyler, I need your eyes over
So
here.
-2.
Yes.
So -2 and 0.
-2 and 0?
Yeah. So,
What?
Or can we keep our positive?
No, it's not that.
Hey, I wanna pause y'all really quickly. I need y'all to pause. I need y'all to remember this. Which form is this again?
Vertex.
So why are you talking about an x-intercept?
That's what I'm free rugged.
It's which form? It's the vertex
Bro, I'm
form.
confused on what's going
With-
on, bro.
We shouldn't be talking about x-intercepts. What form has x-intercepts?
Mr. Kennell was learning like
Factor form. Guys, you need to start to go ahead and study this and make sure you know this. Only the factored form reveals the x-intercepts right away.
Yes.
Because of that zero product property. We have a vertex form here. Notice how when I write above here, and I need y'all to keep that in mind, write that equation out. Because what is H? H is the,
X value.
what is K?
Y value.
Of what?
The vertex.
So why are we talking about an x-intercept?
I don't know who said something.
I just think about
I thought you said somebody X intercept.
I never did. I said, what else do you know?
I
That's
said.
all I said, and y'all started talking about y-intercepts
I
and
said Y.
x-intercepts, and I'm saying, we got what form here? Vertex form.
Yeah, I said something about Y. I don't know who said something about X.
Y'all said X. I was
So,
thinking about that.
first off, we gotta recognize our form.
Yes.
We're looking at vertex. What is my vertex?
-4 and 0.
-2 and 4. -2 and 4. Oh, +4. We gonna switch our sign. Wait, no, we won't. Yeah.
So, I need y'all to remember, right here, x minus h. So I need the, starts with an O.
Opposite.
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 Right?
Yeah.
So I needed a -2, but because it's plus k, whatever's there,
Yes.
It stays the same.
it stays the same. Now, we can remember this and note this because if I were to substitute 2 in, what's 2 plus 2?
4.
4. Do I want a 4?
No.
What do I want?
0.
But if I substitute the opposite, -2 in, what's -2 plus 2?
0.
0. What's 0 squared?
0.
0.
And -2 times 0 is,
0.
and 0 minus 4 is,
0.
4.
Oh, negative 4. Negative
0
4.
minus 4 is
Negative 4.
Oh.
So my input of negative 2 had an output of negative 4.
I was like,
That's my vertex.
I was too deep in with the zeros.
Alright,
Yes, sir.
Alright, so boom, like, if it was like plus 4, so it would be
Right
Yeah,
here,
switch.
it would be plus 4 here. With it, plus K. Now, I will also point out, if you're struggling with this, take the time to just say H equals. Literally, if I look here, what is H equal to?
2.
2.
Negative
Negative
2. I need the opposite, right?
Yes.
What is K equal to?
Negative 4.
Negative
Negative
4.
4. And so there's my vertex, H, comma, K.
I think.
That's all
So
we
it
gotta do.
doesn't, so anything
Just
on
get
K
it.
don't change, right?
The K does not change. If it's a plus, it doesn't change. It's X minus H, X minus R1, and X minus R2. I need the opposite, because that's going to create that 0.
Right.
Now,
Right.
I feel like we're still missing a key feature of this parabola that I know.
The value.
I already have the vertex.
Oh, you talking about?
Why is it?
Yep.
Justification.
Yeah, A.
I already got the concavity.
Justification is getting.
Hey guys, what? Hold up.
Line of symmetry.
Thank you. What feature did we just look at, guys? Line of symmetry.
I thought we were.
Oh, that's right, guys.
That's why it's A.
But what, we didn't write it yet. What is my line of symmetry here?
Negative 2.
I feel like we did.
Oh, I'm tripping.
Negative 2 is close, but that's a number. It's a what?
9
Ah.
What do I need to make it a line?
points.
Put points.
Nah.
Like a graph.
I don't know.
7 comma 6, 7 comma 2.
Oh, you need your Y. You need your Y.
7 comma negative
Your
6.
Y. You need your Y.
Not the x-intercept.
The y
but
The wire itself.
What?
Why?
The Y value. The Y. Oh, the 8.
7.
X equal 8. Oh, X equal, yeah.
Oh.
Come on.
I didn't know that.
You could have told me that.
Bro, what do you think I did
But
here?
then told you.
I can't see from
You
far.
could have told me that the line of symmetry was x equals h, but it's there. All right, look.
I was just thinking.
Hey,
Nah.
hey, pause and remember this. This should help you. Remember, the whole point is to be able to look at an equation and be able to approximately sketch it. Notice, I have the vertex negative 2, negative 4. There's my vertex. And what else do we know about this parabola? Concave. Concave what?
Up.
Down.
Oh, I can't see. Down.
Like frown, man. Down.
Bro, look, I looked at the A on the. I looked at the A on the thing. Yeah, I'm looking at the board. I'm tripping.
Hey, stop and listen.
Hey, party
Hey,
people.
right here. Where,
Hey, I'll pay attention.
Be quiet.
what key point should my line of symmetry go through? Where's that symmetry gotta be?
Wire.
Vertex.
Oh, it's around the vertex.
It's gotta go through the vertex, doesn't it?
Yeah.
Isn't that where there's symmetry?
Yeah, I said
So I
that.
gotta go through the H.
Notice, what is this x value?
Q. Negative 2.
What's, that x value is negative 2. What's this x value?
Negative.
What's gonna be this x value?
Negative 2.
So x is equal to,
Negative 2.
remember, a line of symmetry is x equals, and x equals h because it has to go through the vertex.
Most deaf. What?
If you do not have x equals, your line of symmetry is going to be wrong.
Yeah.
Guys, a line of symmetry is a line, not an individual point or an individual value. It's got to be x equals. All right, at this point, I'm going to come around and support you, but I need you to work with your small group on slide 17. Nope, slide 18. Notice, Vakari, yes, you're going to get practice. Actually, before you do practice, notes to your future forgetful self on vertex form. Yes, because you can get practice. Hey guys, I know, that's why I got to practice. Come on. Everybody else. At this point, remember I just adjusted it. Tyler,
Why soft?
Tyler.
right here. Hey, at this point, we need to be doing notes to our future forgetful self about the vertex form. What features should you, one, write down the equation, but what features should you be writing about on the vertex form graphic organizer?
Everything's on board.
Yeah, but which features do we focus on?
The A, when the age changes. then
So
the Y
A is
changes
changing
to
the
X.
concavity. What other features of the parabola should we be writing about for vertex form? The vertex, right? It's literally what form? The vertex. You need to be able to identify the vertex. What other features should you be writing about? The line of symmetry, right? Guys, I need you to notice your future forgetful self about the equation itself, about the concavity, the line of symmetry, and the vertex. You have a whole sheet for vertex form. Go! Make those notes. Finally sit down. Keep standing. Come on.
Thank you.
Thank you, Amber, for having already taken some notes. Yes. But then I just told you that line of symmetry.
Don't trip, don't fall.
I want to play song.
Don't run, don't trip, don't fall. Don't come in.
Be careful. The line of symmetry is this, but line of symmetry, don't put an equal sign.
What question is it?
Miss Kenny, yesterday, so yesterday,
Right here.
Last 2 minutes?
Last 2 minutes. We are not talking, we're not packing. It only takes me 60 seconds. First off, holy crap, I forgot that don't pack means. I'll ignore you, Mr. Kenny. I'm going to pack anyways.
I didn't pack, my stuff was already
Look,
on my backpack.
right here. Right here. I need y'all to look at this. The first thing I noticed a group doing is I noticed one group saying 1/2 here. 1/2. Which there's a 1/2, right? But what that tells me is we didn't write down our equation. Write down your equation above it, because as soon as I did that for the group, they go, oh, that's not H, that's determining concavity. That's concave down. Second, when I write this, this should be a trigger to help me remember, is that a positive 5?
No.
What does this H need to be?
Negative.
A negative 5, right? Negative 5, negative 6. Last two details. Can a number be a line of symmetry, guys?
Yes.
No.
Can't wait. Can't know.
Can a single number be a line of symmetry? It is every point with an x value of negative 5. That line of symmetry has to be x equals h. X equals 3. X equals -1. X equals 8. Okay? Gotta be the opposite. It's gotta be the h. And it has to be the equation x equals. If I were you, I would do my check your understanding tonight. Hey, listen. You can do the mild and the medium for all your check your understandings. We have not learned a couple of details for the spicy yet, so do not try the spicy section. Mild and medium. You can do all the check your understanding.